Okay, as promised the other day there in class, I'll do a quick demo of how to calculate the second moment of area of an unusual shape using Autocad. I'll change screen and we're going to calculate something as simple as this from one of your other modules using Autocad. Put this onto my other screen just now. And in Autocad, we'll open up a new document. Here we are. And I'm going to assume that you already have some knowledge of Autocad. You will get that within the module itself, which is Mark Taylor's module. Now, there are some commands we're going to use, and the first one's called polyline. We type PL, enter, and we select polyline. And I move the mouse around and it's not going vertical or horizontal. So what I'll do is, I'm going to turn ortho on, and to do that, if I move my mouse down here, and I select this, restrict cursor orthogonally, i.e. vertical and horizontal, and now it's restricted to either horizontal or vertical only. It won't allow me to go to any other angle at this moment in time. So I'm going to move along to the right, and I'm going to type in 240, and that's in millimeters. Then I'll move down, I'll go 15, enter to be 15 mil. Then I'll go back along to the left, 240, enter. Now I could snap on, and to snap on to the end, the box will go green, or I'm actually better to move my cursor away from there, right click and say close. We need our polylines to be closed. And the next thing I'm going to do polyline again. This time I'll go along horizontal. I thought ortho is still on, as you can see. I'll type 8, enter. Come down vertical, I'll go 400, enter, and then I'll go back the opposite way, 8, enter, and then I'll go right click, close. Excellent. And now I'll do one more, polyline PL, enter. I'll come across, 180, then I'll come down, 15, enter, and then along to the left, 180, and then I'll right click, close. Now we've got 3 rectangles. What my next command is called a region. I can type in REG, and it'll come up with all sorts of possible commands. It happens to be a region that we want. And I'll select all 3 of my rectangles. Then I'll right click, and it'll say 3 regions created. At this point, I now want to make my sectional shape, which, if you can remember, resembles something like this. What I'm going to do is I'm going to select this vertical. I'll put move, enter, and I'll zoom in. I'm going to try and grab from the middle. It may be that you cannot grab from the middle when you first do it, and I'll show you how to turn that ability on and off. If we go down here, where it says snap mode, we'll select that, snap settings, and we will go snap object snap, and we'll make sure that midpoint is selected. Well, it is just now. Press OK. Therefore, I can snap onto the middle. It goes to a little green triangle. To the end, it goes to a green rectangle. I'll go back to the middle, and then snap there. Nice and easy. Then I'm now going to select this top element. I'm going to right click just the once, and drag, draw a rectangle over to the left, click, as it's selected, press M For move, enter, I'll snap to the middle, I'll zoom right in with the mouse, and snap to the middle again. I've now got my shape correct. Now it's currently not in the correct location. We need to find the centre of gravity for this object. Now, the easy way to do that is using this next command, but we need to do it twice. It's called mass properties, or MASS, mass prop. And we then select all 3 rectangles, and then right click. And up we come with this lovely sheet of information, and it's that centroid that I'm after. I'm now going to have to write down the numbers 199.399. Is that 0? It is 0. And that's for the x. And for the y, I have 14.6057. So that the 2 numbers I wrote down were these 2 numbers here, the centroid. Now I'm going to click out of that. I'm now going to select, press escape, select the whole 3 of the objects by drawing a fence by clicking and release, drag over to the left, and click once more, press move or M, enter. With the ortho on, I'm now going to move this in the X direction, 199.399. Enter. Now, for you, those numbers will be totally different, all depending upon where you've drawn the object. Now, I'm not quite finished. I'll have to do the same thing again. Click once, drag to the left, select all 3, M, enter, and then move up vertically. I think this time, am I going vertical? I'll double check. 14.6057. Again, that's unique to me. Then we'll go mass prop, MASS. That's mass prop. Select all 3 again. Press enter. And we can see, unfortunately, I moved my object the wrong direction on the vertical axis. So I now need to move it back down to 9.2114. That's this number here. Horizontally, I've got it correct. Right click, and then select all 3, M, enter, and come down the way to 9.2114, enter. Now this time it will be correct. MASS, mass prop. Select all 3 again, press enter, and lo and behold, our centroid is now 0, 0. Perfect. Now we have the second moment of area, or second moment of inertia, on the X and the Y plane, the major axis and also the minor axis. The only thing to bear in mind, the units for this will be in millimeters to the power 4, rather than centimeters or meters. However, it's all very well me showing you how to do this in Autocad, but when you're doing this for perhaps Voitex coursework, please show all your workings and only use this as a double check that what you have got is correct. And you could do a screenshot of what we see here and also pop that in to the coursework submission for Voitex if you wanted to. I find this a very useful tool in AutoCAD, and we use this rather a lot in steel design or complicated timber engineering. and it's a very useful tool, and it's a tool that a lot of people don't even know that exists in AutoCAD. I don't think that this exists in SketchUp or Revit. It only appears to be in AutoCAD, this particular function. In addition to that, we also have radius of regeneration. You'll come across that in third or fourth year steel design as well. So it's not just a second moment of area, there's other useful information as well. Okay, I think that's all that we need for this demonstration, and thank you very much.